In the next part, we're gonna talk about ordering intervals and decimal numbers. So let's get started. So what is ordering? We can order the real numbers that lie on the number line according to their size. So you remember our friend number line. The bigger numbers, they lie on the right side and the smaller on the left. To compare numbers, we use special symbols, which are greater than or equal to, and correspondingly less than and less than equal to. Intuitively, pointed end always points to the smaller number. Just remember that. Doesn't matter where it's located, it always points to the smaller number. Okay, so the rule is easy. If x lies on the right of y, x is bigger than y. And correspondingly, if x lies on the left side, then it's smaller. For example, 2 is greater than -1, and at the same time, it's less than 3. Every number has a sign and a magnitude. If a number is located on the right side of the zero, we call it positive number. And if on the left, we call it negative number. Negative number always has a sign, and positive number, we just don't write a plus sign always in front of them. If there is no sign in front of the number, it means it's positive. The magnitude, which also called as an absolute value of number, in other words, is just simply the distance from number to 0. So this is absolute value. Let's take 5. There is a 5 and there is a -5. So distance for 5 to 0 and to the -5 to 0, it will be the same. It will be 5. That's why it is not negative or positive number. It's a magnitude. In this case, 5 and -5 will have the same absolute value since both of them have the same distance to 0. Subsets of real numbers are also called intervals. Often they are written within brackets or by using ordering symbols. Please notice, since intervals are always subsets of real numbers, we can also write them simply just like this. Intervals could be open, closed, or half open. So what's the difference? So here is example of open interval. What it means? It means that it contains only numbers in between without -2 and 0. In contrast, the closed intervals will include boundary points, so these are included. For example, here x will include -1, and here it will include -2, -1, and 0, and also all possible numbers between them. And finally, we have also half-open intervals, which can include one of the boundaries, either 2 or 0. For example, let's say we have -2 and 0. So here in the number line, we will have including -2, and 0 will be empty because it's not included. So in this case, our set will include -2, -1, but not 0. You got it, right? And this half open interval, for example, will have -2 here and include 0 here. So the set itself will not include -2, it will be -1, 0, and then we close the interval. So on the number line, it will look like this. So we have empty -2, and then we have everything including 0. So also, sometimes we want to include in interval all real numbers bigger or smaller than a. And for this, we use an infinity and minus infinity sign. So example here will be including a and everything up to infinity, like everything. Boom. And here, everything from minus infinity up until a, but not including the a. Okay. And here, everything and including a. Hence, the set of all real numbers could be also written as an interval from minus infinity to plus infinity, or just infinity. As infinity will always have an open interval. Okay, it's not very easy to compare some real numbers, especially fractions or irrational numbers, just by looking at them, and you're quite not sure where to locate them on the number line. For this reason, we can rewrite all real numbers in one unified form of decimal numbers. For example, here we have a fraction 25 fourths, which is equals to 6.25 in decimal system. This is an example of terminating decimal number. At the same time, we can also rewrite decimal number back to the fraction form. For example, 1.2 in this case will be a fraction 12 tenths. Non-terminating decimal numbers could be periodic, which means they have a repeating pattern. They will repeat some kind of same numbers after some period of time. So as you can see, here we have a clear pattern that 15 is repeating itself. And we have 15 here, we have 15 here, here, and we can rewrite it if we see this pattern in decimal number, if we put the bar on top, like this. So this means that the 15 will repeat itself until infinity, and this is example of repeating rational number. On the other hand, non-repeating and non-terminating decimal numbers are irrational. As you can see, this number doesn't have any pattern, and it will just go like this further and further and further. That's why it is irrational. If decimal number is non-terminating, is here example, and it's too long, for practical reasons we can round them and use the approximately equal sign, and it looks like this. Yeah, like curly equal sign. Let's approximate this number here to 2 decimal points. So how we do it? First of all, so we are interested in approximating for 2 digits. So after the 2 digits, we draw this imaginary line and we pay attention to the next number here. The trick comes here. We have to pay attention to the next digit. If this digit is 4 or lower, we call it rounding down. So it means we don't change anything. And in this case, approximation will be 0.95. So as you can see here, let's approximate the same number here, but for the 1 decimal point. Again, as in the previous example, we draw this imaginary line here and we pay attention to the next digit. If this digit is 5 or higher, we call it rounding up. And in this case, we add 1 digit for cutoff number. And in this case, it will be 3.0. I hope everything is quite clear here. So it's a 4 or lower, we're rounding down and we don't change anything. If it's 5 or higher, we're rounding up and we're adding 1 digit to the last rounding point. Let's quickly refresh also computation rules with decimal numbers. As on this example, when multiplying decimal numbers by 10, 100, or any other multiple of 10, we count number of zeros and shift decimal point to the right on the same amount of digits. So as in this example, you can see we have 100 here and we count how many zeros we have. It's 2, right? So we just shift this here and we have it. We have a new number, and it's very easy to do multiplication in this case. Same goes for the division, except we move it back to the left. So as here you can see, this is an example of division. If we move the point to the right for the multiplication, for for division, we move it back to the left. So as you can see here, we count number of zeros, in this case it's 3, and we move it 1, 2, 3. So we put it here. So our answer will be 0.14327. Adding and subtracting decimal numbers is similar to integers. However, they need to be carefully aligned under one another according to the decimal point. Like here, you can see we align them under each other, and then we have an answer. Let's have a look at the multiplication example. Here we have two decimal numbers that we want to multiply. So we drop the decimal point by moving the first decimal points to the right and just calculate it as if it would be just integers as following. So we will multiply 33 to 15 and have 495. And then we see how many points we moved it. It's like 1 plus 1, it's 2. So, and then we count on how many points we moved it. So we moved it one here and one here, it will be one. So we had one here and we have one here. So let me erase it and just eraser. So we have as an example, we have to multiply two decimal numbers here. What we do, we just do we forget about the decimal point and we just make the calculation as if we just had two integers. So we calculate 33 multiplied to 15 and we have 495 in this case. And then we move the decimal point back. So we calculate, we moved one here and one here, so total 2, and then we look at our product and then we moved from the back on 2 decimal points and put it right there. In division, for example, we move decimal point on both numbers on the same distance such they disappear, like here. So we move it to the 2 points here and then we move it to the 2 points here. So we have 248 divided by 40. And then we perform normal division operation and we have a number.